So even though we haven't done a whole lot of programming yet, we can already create a cipher. We can create an Atbash cipher with just a little bit more than I've already shown you. So we've talked about variables, and we've used a few strings, and I started talking about objects, and that they have attributes, and that they have behaviors. So using a string method, which method is just a word we often use in programming for a behavior, we can make an Atbash cipher. So you might be asking, like, first, what is Atbash if you're not familiar with it? So an Atbash cipher, it's a super old cipher. It's one of the oldest ones. It's from Hebrew. It's not a good cipher. It's been cracked plenty of times. It's not hard, but it's historical, and we can do it. So it's a decent start. It is a monoalphabetic substitution cipher. So monoalphabetic means that one letter always becomes one other letter. There's nothing confusing going on about that. Substitution means that one thing is substituted for another. So substitution is like A becomes B, and B becomes C, or A becomes some weird special symbol. The monoalphabetic part means that it always becomes the same one. So the way that Atbash works is it basically just flips the alphabet over on itself. Now, this was originally done with Hebrew because I mentioned that it's a Hebrew cipher, but you can use that with other languages too, and that's pretty much what they've done. They've just adopted it into other languages, and we can do the same thing. So if we take our alphabet and we just flip it, so A becomes Z, and B becomes Y, and then X, and so on, right? Until we get to like M or wherever the middle of the alphabet is. So how do we write this? It's really not very hard. And we can actually even use user input with this. So I'm going to open text edit. Just going to make a new file. We'll start out with a basic print command. And we can do something like that. In a previous video, I talked a little bit about user experience and not throwing everything on the screen at once. So let's use an input command to kind of put a delay in there, right? Okay, so what's next? We need to actually collect the data from the user. So we can put in another input command. Actually, I think I want to add a little bit of blank space, so I'll just print an empty string, and then I'll use an input command. But we need to store it in a variable so that way the computer can actually keep track of it and then apply the different string methods that we use to it. So we'll call this clear text because that's often the term used for the message before it's encrypted. I think I want another empty string just to put a little bit of space in there, and I think I'll use another press enter to continue message. And now we need to actually do stuff with their input, right? The string method that we're going to use is called replace. And you can guess it probably replaces stuff. So we write clear underscore text because that's our variable. That way it knows what it's running the method on. And then we do dot replace. So dot separates this command from the variable name. Replace is the method. We need to put parentheses on it just like we do with inputs and prints. And then we need two arguments to go into here. So I could do like A, and I could do like Z. But since these are characters, they're not numbers, I need to have quotes around them. So A and Z. Now, if I do this right now, the computer will do it, but nothing's going to happen because I haven't told the computer to actually do anything with it. If I tell it to print that, then it should print it. So let's see what happens. I could get further in before running it, but let's just try with what we have so far. So I'll launch terminal, cd desktop, python 3, atbash.py. Welcome to the Atbash program. Press enter, type in your message. I could type in hello, but right now it's not going to work because all I've programmed it for is the letter A, right? So all I can do is type A's. And if I press enter, and one more time, there we go. You replaced all the A's with Z's, so it worked. Now I just need to do that for all the rest of the letters. So we can go back in here and we can just do that over and over again, sort of. If I do this again, and I now replace B with Y, and I save it, and I run it again, let's look at what happens. cd desktop, Python 3, atbash.py, press enter to continue, so it should replace A's and B's, right? So let's alternate those, and we can press enter to continue. Okay, so do you see what happened here? In the first line, it replaced all the A's with Z's, and the second line, it didn't, but instead it replaced all the B's with Y's. So let's talk about what's going on here. If we go back to our code, we used this behavior to change what was in that string, that variable that we stored, but the thing is we didn't restore it in there, so we didn't change the original data. If we want to change the original data, we need to actually store it in there again. So let's, how should we do this? All right, so we could say clear underscore text is now equal to this, but that wouldn't be accurate anymore because we're starting to encipher that text. So we typically call that ciphertext. Ciphertext is going to equal the clear text with the A's replaced as Z's. Now to then replace the next letter, we need to change this. Because we're not going back to the clear text anymore, we need to pull from the ciphertext, so that way it keeps building on what it already has. So cipher underscore text dot replace B becomes Y. And we need to store that, so we can store it in itself. So it's going to replace itself with the string where all B's become Y's. And we need to do this basically all the way down, all 26 letters, right? So A, B, that'll be C, D, E, F, all the way down. I think that's 26. We'll see what happens. So A becomes C, D, E, F, and so on. All right, so we've done the alphabet down this way. Now we need to go back up the other direction, right? Or you can go down backwards, but that's a whole lot harder. There we go. And now at the end, we need to actually tell it to print, right? Because if we don't print it, I mean, it's going to store it, but it won't show it to us, so we won't know if it worked. So now we can tell it to print cipher text. Now we don't need to put quotes around this, because if we put quotes around this, this is now a string that just happens to have the same letters as this. For it to actually print the variable, we need just the name of the variable. So we can save this, and we can run it again and see what happens. All right, so cd desktop, @bash, press enter, type in your message, and let's see if it works. Okay, so there's some issues there, right? It seems to only be partially working. Some letters it changed and some it didn't. So let's talk about why. If we go back to our code here, and there's a couple different ways we can do this. A common way is to actually put in more print commands to try to figure out where the error is. So if we put in maybe a print command here, and we can put in one like here, and let's see if it's working along the way. So run this again. Press enter. Okay, so we can see some interesting things here, right? So on this top line, it didn't convert anything, but nothing was before what? Letter D, letter F, before letter E. The next line, the E was converted, the H was converted, the R, so there's a few letters. We get down to this line, a few more are converted, but some of them are converted back. Like this I got converted back. We go down to this last line, and the E was converted back. So what's going on? So let's talk about it. The issue here is the way that I coded this. this solution makes sense, but there's a slight logic error in here. When we encode the A as a Z, we think, okay, that letter is done, right? But the issue is that string can still be manipulated. And when that part of the string can still be manipulated. And so when the computer gets down to the bottom, where it is then looking for Z's, it sees that Z. So in the word hey, that E, it does change it to a V, but then when it gets down here, it sees that V again. So how do we fix that? The easiest way, with what we know right now, is just instead of lowercase, to use capitals. I'm not sure if you noticed, but the program didn't change any of the capitals. It didn't change the capital H or the capital I at any point in the program. A computer doesn't see a lowercase a and a capital A as the same thing. They're different characters. When you're programming, it's not going to look at a capital A as a lowercase a when it's searching for it. So if we just change all these, all right, and if we save that and run it, cd desktop, Python 3 Atbash, hey, how about now? There we go. It converted every letter into the ciphertext except for that first H. So how do we deal with that first H, right? How do we get it to convert that H without having to put in 26 more lines of code? So there are other string methods that we haven't talked about yet. And of course there are. There's not going to be just one. There's tons of them out there. The one that's relevant to what we're doing right now is lower, and it will change whatever the string is into a lowercase version of itself. So right here we can add in one line of code that will fix it. So clear underscore text equals clear underscore text dot lower. And the parentheses, which we just leave empty, we don't need any arguments this time. And if we save it, rerun it, cd desktop, Python 3 Atbash, press enter. Actually, you know what? Let's really prove it works. Let's do that super annoying thing where every other letter is capital. Isn't that terrible? I think so. But it'll prove if it works. There we go. Every letter has been changed. Not one of them has stayed the same. So that's how you can create a simple Atbash cipher program using just a little bit that we've done already. Now, of course, this is a terrible cipher, but it's a really simple one that we can program already, and you're starting to think about them, hopefully. If you weren't familiar with ciphers, you now know what a substitution cipher is, and you know this is not a good one. So it's a start, and as we keep going, we will work with much more complex ones. And we'll eventually get into some fairly decently secure ones, unless you have someone who knows what they're doing with a computer.